And let's see if it's working. Cool, it is working. Wonderful. All right. Hello, everyone. Good morning. My name is Logan Kilpatrick. I am the community manager for the Julia language. I'm super excited to be joined by Jacob and Miguel, who I know from the Julia streaming community. Jacob, Miguel, do you both want to introduce yourselves really quickly?
Sure, I'll go ahead. So my name, everyone, is Jacob Zelko. If you guys are familiar with my Twitch channel, you guys might also know me as the Cedar Prince. I'm so happy to be joining Logan today with answering some questions, as well as my fellow streamer, Miguel Rauz Guzman, who you guys might know as Brain RPG. So Miguel, I'll let you take it away.
Hello everyone, my name is Miguel Rauz Guzman. I've been coding in Julia since I took David Sanders' computational physics class, and I've been involved with a bunch of translation efforts, and I usually do Julia streams where I'm just trying to solve coding problems, like exorcism or stuff like that. Yeah.
Very cool. Thank you both for being here. I'm gonna mute myself, turn off my video, and then if anyone has Julia questions, feel free to just post those into the YouTube chat, and Jacob and Miguel will do their best to answer them.
Yep, and also if anyone here is joining in from Slack or from the Humans of Julia Discord community, feel free to post your questions there too. I'll be able to hopefully bring those questions in, as well as from hopefully on Twitter. So if I see anything, I'll make sure that they get answered. So let us know what questions you guys have. Yeah, so do you see any questions coming in yet, Lloyd?
Yeah, so it looks like the first question coming from, I apologize if I pronounced your name incorrectly, Dig VJ, and they're asking, is it possible to make web apps, Android apps, and standalone software in Julia?
So
Jacob?
do you want to answer that, Miguel? Or I can answer it.
First of all, I'm not an expert on standalone apps, but I do know that people have made their own standalone. They have shipped their own apps, and I think the tool they've used is Package Compiler. So you should know that there's a couple caveats where it hasn't been the focus of a lot of the ecosystem yet. It doesn't mean that people don't care about it, but it's just a lot of work to engineer that sort of approach for Julia specifically. When it comes to standalone Android or iPhone apps, I don't recall people shipping those yet, but I do know that people have worked on it. So you're gonna have to ask someone else for a more in-depth answer.
Yeah, and I can also kind of jump in with that. Logan, would I be able to share my screen for just a moment?
Yes, let me make sure that you should be able to do so now.
Okay. So jumping on to the web side of things, there's also this fantastic platform called Genie, which allows you to actually make web apps as well as standalone sort of websites. I'm not exactly sure everything it can do yet. The creator of this project, their name is Senshieri or Adrian. Very friendly, very active on the Julia Slack communities as well as the Julia Zulip. So if you have any questions about web development with Julia, he or they might be the person to ask. Furthermore, if you're trying to look into maybe like your own specific solution for web hosting, there's also franklin.jl, which is created by Thibaut Leinart, and he's fantastic to work with, very friendly, very approachable, and he created a platform to actually create. Oh, can you guys not see the screen right now?
We can see your the Franklin GitHub page perfectly.
Okay, you guys can see it. Okay. I I just got a note in my chat saying they can't see it. I'll have to
Oh,
fix my chat in a second.
I can see it on the Zoom call then.
Okay, I'll have to fix that on my chat in just a second. But yes, there's also Franklin, which is a static site generator, and Julia. So those are two possible solutions for web development.
And it looks like there's some other questions coming in. You know, some of the very classic questions, something like, why should I use Julia over C/C++ or Python? And then another one coming in from Marcus asking, what is the main benefit of Julia over a programming language like Python?
Miguel, do you want to start with answering some of those questions?
Yeah, well, it depends a lot on what your needs are, right? So if you're doing, so Julia isn't perfect, obviously. We think it's way better than all of the alternatives in cases where people haven't considered it as much before. And one of the big draws is numerical or technical computing. So anything that has to do with data analysis, machine learning, you know, scientific applications, those are all compute intensive tasks. And if you're a person that comes from Python, then at some point you just start gluing together 6 different languages because you need to pass off to C the code that you wrote in Python because you prototyped it. It's just a classic 2-language problem. And the main benefits that you'd get over C or C++ is more, you get a higher level of expression in your code that allows you to build things quicker and not suffer a performance penalty to the level that you would with Python. That's like the first 30-second answer, but the more in-depth answer would probably be around, what are you doing? It depends.
Yeah, I agree with that. You know, I will say to add to that. So, and Logan, I think you might be able to speak to this a little bit more. I do know that Julia does actually have a certain benchmark about high performance computing when it comes to petabytes of plots being shown, plotting petabytes. I'm not exactly sure what that benchmark was. I just remember it being a big deal because it shows.
I know about it.
Oh, do you know about it, Miguel? Okay.
Yeah.
How
So
you talk about that some more?
Yeah. So that's really like one of the really cool performance achievements that Julia made to be considered like, okay, like it's clear that we're in the big league. And it was, so that project was called Celeste, and it was run out of the Berkeley University in San Francisco supercomputing center, I think. And what they did is they had to, there's something called the Sloan Sky Survey, which is just a huge astronomy catalog of a whole bunch of astronomical objects. And it's a ridiculous amount of data. And the idea was that, you know, there's all this data, but it's very hard to label all of it. Like you'd want to be able to say that there's so many stars that fit within certain categories or that have certain properties. And to do that, you obviously can't do it manually, so you need to be clever about it. And one of the clever things that you had to do was a Bayesian approach to it. And the Bayesian approach was heavy on the statistical computational side. So you needed to coordinate processing a ridiculous amount of data with a ridiculous amount of computers. And so the team that involved Keno and Simon Danish and I think Jarrett Revels and a whole bunch of other people on the Berkeley side, and like it was just a huge collaboration. They had their own code, and then they had in like the Julia gurus come in and help out with their performance. And so it's a massively parallel distributed computation with a ton of GPUs processing a whole bunch of data, and they were able to reach, I think, a petaflop or something ridiculous. So the point is, I can't remember the exact number, but the point is that they reached a benchmark for processing that very few other languages have reached, like in the history of mankind, like ever. So that was pretty cool.
Yeah.
Oh,
Logan,
right.
Do you have anything to add to that, Logan?
No, I don't have anything to add, but one of the follow-up questions was um, Emissary Prague asked the question, is Julia aiming to be a language for ML/AI research as well?
Yes.
And if you're
Yeah.
not signed up for the Julia Computing newsletter, the very top of the Julia Computing newsletter that just came out today should answer that question for you. But Jacob, Miguel, you guys can take that.
Yeah, Miguel, you seem kind of excited to jump on this question. Do you want to
Yeah.
jump
So
on
if you're
it?
so there were two talks that came out this week or last week that are about like the bleeding edge of compiler technology and language design, and those are Matt Bauman's How to Differentiate a Trebuchet, I think it's called, and then Keno's talk at Rebase conference on bringing category theory to compiler transform. If that sounds like gobbledygook, it's basically you need really clever math to make sure that some of the key compiler optimizations that are essential for really bleeding edge machine learning algorithms happen correctly. And they figured it out, and they did it in Julia. And Julia is likely one of the few languages that has the native capabilities for doing all of these transformations and optimizations out of the box, right? So I don't know, you could probably do it in, like, there's some other cool contenders. I'm not an expert. Like, there's people very excited about stuff like JAX or TensorFlow or other stuff like that. But it's the ability to do these things in Julia is quite amazing.
Yeah, and I'll jump in on that. So I'll go ahead and share in just a moment. I'll share my screen, but yes, I would absolutely say the resounding answer to that question of is Julia, situating itself to be a language for machine learning and general studies in artificial intelligence? The answer is a resounding yes. There's even the other day, I believe it was a very famous. Do I have his book on my shelf? No, I don't have his book on my shelf.
Oh yeah, the Google AI.
Yeah. I think that was it Russell Norvig or Peter Norvig? I can't remember his full name off the top of my head, but basically he's kind of, if you've taken an intro to artificial intelligence course in your undergrad career in a university, not only across the United States, but maybe even across the world, most likely you've used his textbook, and the author of this textbook just came out and saying yesterday that basically Julia looks really great for the future of machine learning technologies. And if you aren't convinced by people like that, there is a strong and growing community of artificial intelligence research and work going on in the Julia community. So one of the kind of big packages in Julia right now is a package called SciML, or really it's not even just like one particular package, it's a whole organization. So let me just go ahead and pop that up on my screen so you guys can see that. And that is that is a really great, really strong group. So, here's a SciML group working on things such as differential equations, another package called Flux. I'll show you guys Flux in just a second. The person that's kind of spearheading a lot of this is Professor Chris Rackauckas over at MIT. So, you also not only have, brilliant people working on this, you also have that, people at MIT are using Julia to perform these sort of operations. And there's also the famous Flux library in Julia. So if we go to flux.jl, that's another one that is very commonly used for machine learning in Julia community. So I will just say that yes, Julia is certainly positioning itself as a tool for machine learning, and it has been for quite some time. So that's just kind of my answer to that question. I encourage you to continue exploring the ecosystem. If you have questions, please just come on to the Julia Slack. You can just look up Julia Slack, and you can join our groups there, Zulip, Discourse, and ask your questions about machine learning, because we have a lot of brilliant people involved in the community who would love to show you how Julia can be used for ML.
Here's an interesting question coming in from Div Yanshu, asking, how does one keep up with all the constant improvements happening in Julia? There's so much development across the package ecosystem, the language itself, which is super positive, but it's also difficult as a developer and user to keep up with all those changes that are taking place. So what are some things that both of you can suggest to sort of keep up with the pace of innovation?
Yeah, I'll go ahead and start with answering this question. So in my experience, so I've been responsible for a somewhat popular package in Julia called Javis, which is specifically created for animations and visualizations. And that is a question that my collaborator, Ola Kroger, otherwise known as Wakunia, he and I have been kind of having to deal with. And the principal thing that Julia has to really help make, here's Javis, by the way. But the principal thing that, has helped make our lives easier when it comes to development is what Julia has, which are TOML files, which allow you to actually specify compatibilities with packages within the Julia ecosystem, and being able to easily make sure your packages are, the right version number, the right, Julia's the right version. So that way you actually have this ability to have reproducible packages that are somewhat frozen for that package that you're developing. What we do run into, like you said, kind of like what you're implying, is that problem of dependencies. How do we best handle dependencies? And the answer that I kind of have there is kind of not. It's not the most elegant answer, as it's honestly a very great question. My thing that I do is I try my best to be looking at GitHub, paying attention to like Julia Slack. On Discourse, there's actually a specific tag that you can look at called ANN, which stands for, I forget what it stands for, but it's basically a new package announcement. So you can see like when people are releasing new packages or updates to packages. And right now the information is somewhat, I agree with you, is somewhat disparate. I think Julia Hub is doing a great job at trying to coalesce all that information together. But my best way that I've been able to do it as like a Julia developer has been, looking at, Discourse, Julia Hub, being apprised of, conversations in the Slack community. Thankfully, like information like that is not so far out of reach. So that's just kind of the general thoughts that I have as it relates to keeping up with the general flow of Julia. And maybe Miguel can also talk about, I've seen Miguel being very excited about Julia version 1.6 coming out, so maybe he can talk about that as well. So I'll let him.
I don't think so. We're STEM-sided people, and I think the best people that can actually answer with how do you keep up with human knowledge are more on the humanities side. And I think the basic anthropological answer is just get to know people and they'll point the way, right? So the answer is basically the community. Yes, there's a ton of fun stuff happening. Yes, there's a lot of exciting projects being built. I guess the best answer, I don't know that it's the best answer, but one good way would be try and help others build cool things. And then people will organically help you stay in the loop if it aligns with your interest, right? Like the Julia ecosystem is particular for allowing a lot of cross-pollination across domains of ideas. So you have people like Tim Holy, who's a neurobiologist working on compiler optimizations for arrays, or you'll have economists who are really good at doing statistical tools, or maybe the physics people are like working on the differential equations that help out, the people who are modeling something else. So I don't know, like it's a lot to keep up with, but just hang around people and hopefully they'll be kind enough to answer any of your questions. I'm seeing this question by Bravish Ghosh on the YouTube chat. Do you mind if I answer? How to contribute in Julia organization and Julia open source?
Yeah, take it away, Miguel. That's a great question.
Yeah, so Bravish, great question. We're actually, So first of all, we welcome comments on how to make this easier. Uh, the best idea would be to ask, what are you interested in? There's a couple tools that are very useful to know, like, hey, like using Git is going to be really important. We're working on tutorials for on-ramping beginners and letting them know like where the community is, like how you can contribute, what you can actually do about it. The probably easiest thing, maybe I can share my screen. Yeah. So Kathy, that's probably the best thing that you can do. Let me try and share my screen, and I'll show you the blog post that is actually talking about all of this. Beginner AMA. I should be sharing my screen. Yeah. So this is a really cool blog post by an amazing contributor to Julia called Dr. Catherine Hyatt, right? And she's super cool, and she made this blog post called "Making a First Julia Pull Request." And her approach is basically add tests or add documentation to the package. This one deals with base Julia, so there's a couple more considerations that happen. You'll need a GitHub account, working just a little bit of Git, but it goes over the entirety. And basically start adding tests or documentation. Almost everyone welcomes that, right? So read this post. This is a really good post to start getting set up. If you don't feel confident enough to get set up with this, feel free to come into the Julia Slack or the Zulip and ask us questions about it, and then that should be able to help with some of it. Bravish, I hope that answered your question. So yeah, I'll stop sharing my screen right now.
Yeah, and I'll jump in kind of talking some more about that too. Also, that's just, it's super cool to see Dr. Hyatt being highlighted because she was actually, in case of people didn't know, she actually does have a Twitch channel as well. And I think her handle is K Slimes. I can't remember off the top of my head, but she was actually one of my inspirations for getting started with Twitch streaming. So it's very cool to see her work being highlighted.
Oh yeah, she did start streaming.
Yeah, she did. It was a while ago, but I don't think she's done it recently. But you know, that was a fun blast for the
Catherine,
blast.
if you're seeing this, we miss your clickety clack keyboard.
So we miss you. You're amazing.
Yeah, you're welcome back anytime. But we understand that it's tough.
Yeah, and I will also. So I'll go ahead and share my screen actually real quick again, just very quickly, because also there is something that I did want to highlight, which is the Julia Seasons of Contributions. Basically, there's multiple different ways you can get involved with the Julia ecosystem, the open source ecosystem, and that is at julialang.org/JSOC. And you can see all these different projects that you could work on that are all related to Julia. And I'm sure Logan might want to add something to this, but I just wanted to highlight this to show that yes, there's a lot of different ways people can get involved in the open source side of Julia. We love open source contributions, and we're eager for your first PR. So,
let me try and answer a question that came up in the chat, and this is a question by Ali X, and it's about what is a REPL and what is a REPL for a beginner. So we can actually try and.
Are we doing it live? Are we doing it live, Miguel?
Are we doing it live? Yeah, maybe. Terminal. Let's see. Let's allow. Yeah. Am I sharing my screen? This is a REPL. Yeah. So give me a second. We're increasing the font size. So Ali, this is a REPL. If you install Julia, if you just Google Julia download 1.5, no, and then you click, and you download everything, and then eventually you get to something that looks like this. And then you can do stuff like, I don't know, calculate what 3 plus 3 is, or you can do stuff like defining your function, right? So you can do stuff like that. That's one of the basic programming environments. If you get more comfortable with coding, then you're going to want to do more stuff like working with a text editor. But did you see how Julia like evaluates, prints the result, and then does it again? That's the read, evaluate, print loop. That's the REPL. And so let me show you this other thing I have, which is this video about tips and tricks for beginners. And this tips and tricks for beginners is located. I can't seem to share the link for it, but I made a video specifically for beginners about that, right? It's called Julia REPL Tips and Tricks. Let me try. I can't share it on the YouTube because I don't have permissions for that, but let me post it.
Miguel, if you just post something in the random in the chat, I can give you moderator permission so that you should be able to put.
Oh, that's excellent. Yeah, so here, let me get moderator permissions and I'll post that for you, Ali. So yeah, thanks. That's it for me.
Yeah, and actually, so I fully 100% recommend Miguel's video. Actually, when I was first starting my Julia adventure, so I only started programming Julia maybe seriously back in like May of this year. I experimented with it a little bit back in December of 2019. But Miguel's video is one of the first ones that I saw to actually like teach me some of these tricks with using like a REPL in Julia, because it's a lot different from things like REPLs in Python. So you actually have a lot more interactivity, I feel like, in the Julia REPL. And also to maybe just answer the question of what is a REPL and what is it, for Julia development. So at a very basic level, it just allows you as a programmer to quickly prototype ideas and try different things out. Also, I will say what a REPL in Julia is typically used for is people use the package called revise.jl. Now, granted, revise is a little bit more complicated for a beginner jumping right into Julia, but essentially you just want to, whenever you work with the Julia REPL, just to say, using revise, and you can just kind of forget about it, let it do its work in the background, because what revise does is, say if you have a function that you define in your REPL, or some program or some software that you define in your REPL, revise handles updating everything back through your REPL to make sure everything's up to date with where it's at currently. And what that means is you don't have to worry about keeping track of all your variables, because the REPL will do it for you. And also what I should say is, typically for most Julia programmers, whenever we actually develop Julia code or scripts or whatever, we tend to actually have the Julia REPL running in the background and running our code from that. So unlike Python, where you'd say, like, from your command line, if you've ever worked with Python, like Python myfile.py, run my Python code. And Julia instead will start up like Julia REPL session, and then from there include our file, and then whenever we want to run our file, we run it directly from inside of the REPL. We don't really usually do Julia myfile.jl, just because what that will do is you'll have to pre-compile all your packages that you're using for that particular script every single time. So whereas with the REPL, if you start your REPL, include the file one time, the performance penalty of having to deal with pre-compilation is taken care of for the first time, and then you get the lightning fast performance that you might see in just doing Python myfile.py, for example.
I have a really quick two-part question for both of you. So the first part of the question is, what do you both of you think makes Julia so uniquely suited for scientific computing? And then the second part of that question is from math4datascience.repository, who asked, what is the best approach for big data handling? That might be a tough one to answer. And then asking about the Julia DB organization. Is it obsolete? Is there a better one? My quick 2 cents is anything made by Jacob Quinn, who's the person who made Julia DB, is a gold standard package. So definitely not obsolete, and definitely Yeah.
Yes, very strongly second that for sure.
So this is not take this with a grain of salt. Unlike why is Julia so well suited? Like, don't take my word for it. Take the just look at the packages that exist. So Julia is a young language. It's been in the world for like almost like not 10 years, like something like that, and it's already overtaking established players who have been in the game for decades. So if you're an incumbent, you better you better be punching above your weight and against really, really, really competitive um, established players. And Julius A doing that, and B. So if you want reasons for why that happens, I mean, we could talk about the community, we could talk about the design, you could talk about everything. I just think it's the fact that so there's many of them. One of them that resonates with me is the fact that Julia's code is so composable. By composable, I mean that I can take somebody else's code and use it on my own code base and not take a performance hit and have it work out of the box. Essentially, that means that I get to reuse everybody else's work. So, I mean, that's always that's true in many other languages, but the extent to which it works in Julia is almost, I don't want to say unprecedented, but it's surprising. You basically have exponential growth with how complex your or with how much behavior you can express because you're always using somebody else's code. Like you can always grow that. Whereas what happens with a lot of large scientific endeavors is that they have to start with some basic consideration like we cannot afford to have this data representation. It's like, oh, guess we can't use the boost library out of C++, or we can't use their driver for parallelism. Like these things just don't compose across these mega projects. So you're just stuck with re-implementing Newton's method again on your particular super specific data structure or whatever. So that having to restart again all of these massive projects, it's just an amazing redoubling of effort. And you don't face that as much in the Julia ecosystem, right? So my answer is basically exponential growth.
Yeah, and so kind of jumping on from it from like a different angle to answer those questions. So to kind of give more of a hands-on approach, so my background, I'm involved with some of the healthcare field, biomedical informatics world, and so I've been looking at specifically lately EEG data or electroencephalogram data, which models how much electrical activity is happening across the brain. So I'm working right now with a data set that's about 10 gigabytes. So I mean, it's not like a huge data set or anything like that. But I'm having no issues with that using Julia. And in terms of scientific computing, what drew me to Julia actually, so before Julia, I was programming in Python for about 3 or 4 years. Also, experimented with C++ as well as MATLAB. What drew me into Julia was, definitely, I'd say first initially the speed idea, but then what quickly became apparent was the flexibility that you have in the language. For example, this is kind of funny to say, just because I feel like it's so ingrained in so many people. Is I have actually never used once object-oriented programming in my Julia programming experience so far, which is just very fascinating because I was very heavily in that mindset of object-oriented programming in Python, and I can still switch to Python and do object-oriented programming fine. But with Julia, they have a very specific construct called multiple dispatch, which allows you to basically get away, solve the problem of object-oriented programming, which is fascinating. So I encourage you to check that out, as it simplifies your code a lot more. But coming back to the original question of what personally drew me into the Julia programming community was the fact that the speed, the flexibility, and also you have the speed, you have the flexibility, and you have the readability. If you look at Julia code, it's honestly very readable. It's very similar to Python, and that's something that I love because I feel like too often we kind of have this sort of for lack of a better word, like tribalism kind of around languages. There's this high barrier of entry for people who want to learn programming to join the get involved with using programming. Like if you want to learn Java, you have to do like system.out.println, all this weird sort of stuff at first, and you're like, what is this stuff? Whereas with Julia, you can simply type into the REPL print space, print parentheses, hello world, and it prints it automatically for you. And combining that all together, I think as we continue to increase with our production of data across the world, like it's an exponential increase every single year. I think Julia is very well fitted to actually extract the positive, this meaningful signal from all this data that we're generating into an actual useful form, because we need the ability to quickly process this data. But the problem becomes if we don't have readable or accessible tools for people to really dive into this problem, you're going to have less people working on this problem, because for example, say if you want to use Python to really dig deep into some parts of data processing, you'll quickly run into C code, because Python wraps around C to really get its performance. Whereas with Julia, a lot of Julia packages, code in Julia is written in Julia, so you can actually just keep digging into the code and actually kind of have an idea of what's going on.
And just to echo that, like there's such a smaller difference between a user and a library developer in Julia. Like in other languages, like Python, it's like I'm a user of the libraries. Like I have no idea how the C interpreter works below the hood. Whereas in Julia, you can just always kind of read Julia code. Like I know it's scary at first to like think that you're reading source code and that's like voodoo magic or something, but it's really not that big of a step. And there's a lot of tools that help you like peek into like what is going underneath the hood. Like I keep thinking about like if you're driving a car and the entire motor was invisible and you could see like all the oil and pistons going around, like even if you never driven a car before, like you could just see where all the things go, and you're like, oh, I guess it's important to like plug in the oil every now and then or something. Like it's just so much, it's so easy to introspect into what's going on like below your code that you gain those skills quickly.
Yeah.
I really quickly want to echo something that Jacob said, which was about what makes Julia so well suited for scientific computing with respect to readability. And there's a lot of examples of people, scientists using Julia, sharing their work on the Julia language Twitter. But if you actually look at some of the research papers and the actual raw math that they're using, the comparison Julia code is very, very similar to the math in its pure form. So for scientists and people doing scientific computing, when you're sharing your work with other scientists, you can share the Julia code and it actually looks like the true math, which is super helpful.
The whiteboardability of your implementation is a really underappreciated aspect, right? Like you can look at the code, the paper from the pseudocode from the paper and the Julia implementation, and it doesn't look that different, right? Like you can sort of, in many cases, it's almost verbatim, but it's very, very friendly. And oh God, we love Unicode.
Yeah.
It's so nice to be able to work with all those nice math symbols and.
Yeah, and to kind of answer the latter part of that question, when it comes to like the the data handling community or like the data handling and Julia. So right now, as Logan was saying, we have a very strong what's called Julia data organization within the Julia community who does a lot of things looking at implementing the different file formats. Like for me, I've been working a lot with the Apache Arrow data format, which is kind of the successor to the Apache Feather IPC format. So you actually have like a native Julia parser for the Arrow format in Julia, and I've actually been able to use that to really fast and easily open up Arrow, like Apache Arrow based files and formats and stuff like that. There's also I think there's a Parquet reader that's actually being worked on, and I think it's actually starting to be in production now. There's also, we have support for data frames, which is just called dataframes.jl by Bogomil Kaminsky, and hopefully I said his last name right there. But that's a wonderful package, very similar to like stuff like pandas that you might see in Python. And there's even in Julia certain packages that allow you to interact with directly with Python. So there's pandas.jl, which provides like a Julia user interface for pandas data frames. So you actually get the ability to work with pandas data frames, but you're just doing it in Julia instead. So you have this wonderful kind of feature parity between the two different languages. And coming back to Julia DB, I personally do not know too much about Julia DB. I have seen some discussions just also asking that question about what is the feature of Julia DB. I do know, like as Logan was saying, the Julia data community is still involved with it. Unfortunately, we just don't have someone from the Julia data community to better speak to that on the chat right now.
But come to the Slack, ask people about it there, or the Zulip, yeah, or the Discord.
Yeah, can I ask myself? So I actually have a question from my chat. Is it all right if I bring it in?
Yeah, go for it.
Is that cool with you, Logan?
Yes, of course. You guys are running the show.
I just know we have like questions coming in from everywhere, so I just want to make sure. But okay, so the question, and this is a great question, especially for people just getting involved with Julia. So, how do you recommend speeding up the development process in Julia? I find myself repeatedly restarting the REPL as revise doesn't seem to work with updating the types of fields and composite types. The long startup times really are the main drawback. So what do you guys want to say to that?
Well, it depends on your application. If you're very sensitive to startup time and there's a couple libraries that are heavy to load, you should look into baking your own this image with package compiler.jl. If you go into the documentation, let me try it. So here, let me, I'm not able to show it right now, but I'll share it in the YouTube, because package compiler will basically, you know how in Julia, when you start up, you already have like a bunch of libraries already loaded, like you didn't have to load, I don't know, strings, or you didn't have to load like the numbers. You do have to load linear algebra now. So that all of that is baked into the initial Julia system image, and you can modify that with your own packages. So I have it set up so that benchmark tools and all my REPL and revise are baked in. So I get almost zero startup from loading up those libraries. So if you are forced to be starting constantly, that can take a lot of the hit away. The other way is that maybe there's something like we'd have to see like what your workflow is like about being able to use revise appropriately. I don't know if it's a limitation that it can't handle type definitions and redefinitions. It usually happens like more at the beginning of a project where I'm like working out the structs and the dispatches, and then after that it's more like recompiling functions. So we'd have to see what your workflow is like. But yeah.
Yeah, and to jump onto that, so getting back to kind of what Miguel was just saying right there at the end about composite types. So yeah, so like, you do have the issue with structs, for example, where say if, I was working on with just recently a struct where I was trying to find part of my visuals, like part of my brain project, my EEG analysis project, and I was trying to find a struct that contained information about the subject that was being examined, how long the session lasted, that sort of thing. And yeah, I'd run into the issue where if I try to modify my struct, it'd be like revise would kind of say warning, redefinition of or incompatible redefinition of like this type. And the way that I've seen people get around this, and actually the way that I do it, is when you're first initially prototyping before you come to a final conclusion about how you want your struct to look, is I use a name tuple instead. So you can still have kind of like the struct type syntax, but instead of it being an actual composite type struct, rather you can use a name tuple where you can actually have some redefinitions coming into play.
Oh yeah, so yeah. If you're a beginner, name tuples are like anonymous structs, if that makes any sense at all, and they're pretty cool. But if you don't know what those are, don't worry. Just uh, get started, and you'll run into them eventually. Uh, oh, Ludovico, thanks for the shout out. Seeing this on the YouTube chat right now. $1 question. Julia 1.6. When? Nobody knows. Soon. PM. Mm. Oh no, the feature freeze was yesterday for 1.6. Says Oscar Smith in chat. So I don't know. Soon. You can always just build master and use the main branch of Julia. So you can get all those benefits if you want to live on the bleeding edge. But yeah, I mean, it's a lot less scary to live on bleeding edge now than it was like in the pre 1.0 days. What can't I live without from 1.6? Parallel precompilation. So if you haven't observed the speed ups that parallel precompilation brings, you should definitely check it out. So parallel precompilations, for those who don't know, is that let's say that I want to download the entire differential equations package with like all of its subdependencies. So instead of downloading each package and then like compiling every single one as I use them, the package manager will now start downloading all of them and pre-compiling as many of them as they can. I think. I'm almost sure. But the point is, loading packages and installing packages is a lot faster in 1.6. And there's a really cool little prompt that goes around. And I think most of that work, the last effort was done by Ian. I can't remember his last name. So shout out to Ian and the rest of the compiler crew who worked that out. Jacob, I think you're muted on the call.
Oh, yeah. So I was just looking at the other questions. So I actually see a question coming in from the Julia Slack community. So thank you everyone who is joining from the Julia Slack. So this is a pretty cool question. Hopefully we'll be able to give some thoughts to it. So here is the question. What is the status of using Julia for GPU computing? Why Julia for GPU computing versus alternatives? And I'm going to assume that the alternatives that they're talking about stuff like Python, C, maybe even some services. So why Julia for GPU computing, and what is the status of using Julia for GPU computing?
So you want to take a crack at it?
Yeah, I can take a crack at it. I'll try my best. So I have to admit, so full disclaimer first, I did not work a lot with GPU computing. Actually, this we mentioned her earlier. So Dr. Katie Hyatt, she actually does a lot with the Julia GPU community. So let me actually share my screen so I can show you what I am talking about. So here we go. So the Julia GPU community is thriving, it is active. There's a lot going on, and Dr. Hyatt is actually pretty heavily involved with this. So we have interfaces for things such as CUDA, 80 AMD GPUs, Vulkan, OpenCL. As you can see just from this kind of list. So Julia computing on GPU devices is certainly supported within Julia ecosystem. Now, as it comes to the latter question, why Julia computing on why do we want to use Julia for GPUs instead of other alternatives? And I think the best way to answer that is to kind of go back to more of a simple question. Well, the simple sort of like how we answered some of the questions earlier, which is just simply that. Hang on, I'm thinking about how I want to answer this. So how we were talking about it, how we were talking about computing earlier in Julia is, we have that ability for multiple dispatch. We have that sort of ability for different styles of computing where you wouldn't necessarily have to worry about the cost of code decay, which is, that idea of, over time, how well does the code hold up, or in terms of readability and perhaps even legacy code. However, though, I wish I could give a better answer, but like I said, I do not have much experience with GPU programming using Julia. Perhaps Logan or Miguel can.
I can try and chime in as another non-expert. So we're gonna have to get someone from the GPU computing stack answer. But I do have an answer. I think I asked this question to Kenno Fisher at a JuliaCon, a couple of JuliaCons back, and he had a really cool answer, which is that why is Julia really good at GPU computing? And the answer is not specific to GPUs, but rather in Julia, you have a lot of facilities that make libraries in Julia more powerful than libraries in other languages. What do I mean by that? So in Julia, some libraries could they be considered compilers in other languages? Kind of. Like, you have so many tools to like modify your code with macros and writing like these domain specific languages, like adding so much sugar that will handle the computation later on. So it's very easy to keep things looking simple and then not have to worry about like the logic of how to actually manipulate all of the expressions so that it fits into a certain paradigm. So what's really cool is that you can use macros and you can use the type system so that you can write code once and have it run anywhere. Like that's been a maxim of the Julia developers for quite a long while. Like we do not want to rewrite our code, like the supreme efficient laziness principle. So there's been a lot of care that's gone into figuring out how you can have generic code. And generic code means that it will have the same behavior independent of the type. And so if you can manipulate the type in a clever enough way, then you can have it target different behaviors. And that will mean eventually, and that means you can target different architectures as well at the software level. So you can have your code compiled for GPUs or for TPUs or for the newest coprocessor that's going to come around. Like that's like almost compiler level like considerations for specific optimizations. But you can do that natively within Julia because of all the metaprogramming capabilities. My basic answer is you have such an easier time manipulating Julia code itself within Julia that's why it makes it a lot more feasible to just write GPU-able code within Julia. Like just look at the code bloat of like trying to call a CUDA kernel from like C++ or Python, and then just look at it from the Julia like, oh, I just declared my Q array and off it went. Like that's using Q arrays and then that's it. Almost like one line changes will lead to like just amazing composability. Oh, yeah. So I'm looking at the chat right now. If you're more interested in that and you want an actual expert's answer, right, then you should look into the GPU office hours on Monday. So check out the links that are in the YouTube right now. And there's people that just hang around for like a couple hours every Monday, and they will be like, they'll let you know, they'll let you ask your GPU questions there. So yeah, great plug. Thanks for that, Maud.
Miguel, Jacob, we're running out of time, but are there any last minute questions from the YouTube chat that you think might be important to answer? I see a couple of different ones, but if there's a particular one that either of you are interested in, feel free to.
Yeah, no.
Nothing burning.
So, Logan, you might want to pick them out just because I'm manning the Discord and Slack and my Twitch and everything. So if you see
Yeah,
something that you think is burning, ask away and we can answer it.
yeah. So I think the question that we'll close with is, when would it be appropriate to use package compiler and revise? Sort of what stage in the development life cycle would those tools be helpful to somebody?
So I don't know for everyone's workflow, but what has worked for me is to, like, I know that there's like 3 or 4 packages that I always want available on startup, and those are revise, my REPL, and benchmark tools. And so those I use package compiler for, and so I'm just jumping in and out of the REPL into the text editor, and that lets me quickly modify behavior and check that it passes tests. So it the pitfalls would be, so what if I'm deving a package, if I'm creating like YouTube question answerer.jl or something, like it would be silly to package compile the sys image for that package every time that I make a modification. So it's more like I package compile my tools that let me work on that project, not so much the project itself. Once it's stable, then yeah, that makes sense.
Yeah. So, did you have more thoughts to add real quick?
No.
Okay. And real quick, just for my brain, could you repeat the question one more time, Logan? I apologize.
It's during what part of the development cycle do you think that package compiler and revise are worth it?
Yeah. So so with revise, I would say revise is advisable. Like, I kind of alluded to it a little earlier. Revise is applicable, I think, at any time during the development process, personally. So I would say, even if you're just doing some scratch code where you're trying to figure out, how do things work, using the REPL, I'd say revise is applicable then. Along the development process, I'd say revise comes into a lot of really great use especially when you're working with a lot of different functions and you want to just maybe modify, one function from your code. So that way, things don't blow up on you when you're working in your REPL. So I'd say, it's very, very useful and very applicable at any time. In respect to package compiler, I would say with the package compiler, for me personally, so I'm a bit of an oddball. I actually haven't much experimented with package compiler just yet, which is really, I think, sad. I really need to do it at some point, just because.
Hey, we're all beginners sometimes.
Yeah. We're definitely and also that's on that note, just for side tangent, for anyone who is just coming to Julia, it's not like we're rock stars when it comes to like programming or anything like that. Like we're just having fun with this. And, I think what Julia enables you to do, and I've seen this said from a lot of different people, is Julia feels like you're actually having a lot of fun while you're programming. And it does. And, that's why I'm so thrilled about that. I feel there's like a low barrier of entry to just programming Julia in general. So, there's plenty of resources as we've been talking. But to answer that question of the package compiler, I would say, it depends on your workflow. Is my answer.
And just to dovetail off what you just said, like, we're clearly not experts, like to the level of, because we hang around the people who like legitimately started the language like from scratch, or at least we see them post every now and then on the Slack channel. So hola Diego. But what we do get is that, so knowledge is a social activity, or sorry, knowledge is a collective activity. Knowledge gets produced socially, and if we don't know all the answers, like somebody in the community likely will. So please feel free to if after this you just want to ask where to start, feel free to send at least me a DM or whatever, and just be like, hey, like I want to get started. Like, what's a good pointer? If I don't know, maybe I can point you to someone who does. And then we've had very, very friendly responses from a lot of people on getting started. So feel free to reach out, and hopefully we've done some of that reaching out during this event. But if it didn't work for you, then let us know how we can do better.
Yeah, and that is very last thing, very last thing. So with that being said, if people, and if you do have a negative experience when it comes to working within the Julia community or with people within the Julia community, please let the right people kind of know about your experience, because there is a lot of initiative to honestly make the community a lot more open, accessible for people of all different backgrounds. The people that you might want to talk to, you run into those negative sort of issues. Is, Logan in the chat right now. It could even be like, reach out to Baral Shah, who's one of the creators of Julia, and he could probably point you to the people that you might need to talk to if there's like a particularly negative experience that you're having. Because with the community, we want this to be, something that's open, accessible, and what we mean by that is, having it be open for all, not just like of one type of person. That's why, we're emphasizing, like Miguel and I feel like are emphasizing that we're not like, these amazing rock star programmers or anything like that.
But we're getting there.
We're getting there.
One coding stream at a time.
One coding stream, one issue at a time. But we want to make it open and approachable and friendly for everyone here. So on that note, I'm done talking. I'm sorry, Logan. We'll let you close now.
No, you guys are good. I appreciate both of you for taking the time to do this. If you're watching this video and you have more questions about Julia, or you want to get in contact with Jacob or Miguel, the Julia language Slack is a great way to do that. And you can also find Jacob and Miguel streaming. If you go to julialanguage.live, you should be able to see their Twitch links.
Yeah.
Any other closing thoughts? Otherwise, we'll go ahead and end the live stream.
Yeah, I actually had one. Can you guys hear me real quick? Okay. So I did have one final thing. So this is something that I'm kind of passionate about when it comes to the Julia community that I'm seeing starting to happen. Is we are, and maybe Logan, I think you'd be probably the better person to talk about this, is we are definitely trying to bring in more, increased discussions around diversity within, the Julia community and just computing in general. And I've seen like a lot of great conversations starting to happen. Well, not even starting to happen, they've been happening with the Julia community. And, that makes me, just very happy as someone, me myself personally, I'm very, try to like on my streams, and Miguel does the same thing. We try to be very open with everyone, regardless of whichever background you come from. And so I've loved seeing that kind of discussions and growth happening. Do you have anything to kind of talk about with that discussion, Logan, or things to add to that?
Yeah, that's a really good question. I think the biggest thing that we can do is continue to do live streams like this, and work off of other resources to sort of make sure that that there aren't artificial barriers to entry for people who are interested in learning Julia. So I think that's the biggest thing, and we're going to keep doing these live streams every month and work on other resources and initiatives. So again, thank you everyone for being here, and Jacob and Miguel. It's been awesome.
All right.
Take care, everyone. Thank you.